So, well, I got a big voice now. This is how we get our messages across to management, with that big voice. So welcome, everybody, to the after lunch session with Matt and I. And we're going to talk about visualizing your data, exploring it, using JMP's mapping capability, and just sort of how we kind of went through the data and the fun that we had in our particular journey. You're probably wondering a little bit how Matt and I know each other and connect. Matt is at Aetna and I'm at JMP, but we've been friends for quite a while, and JMP's been our common conversational piece. So one day I was talking to Matt and I go, I got this JSON file, Matt, and I'm trying to get that, and Matt, in his infinite wisdom, in 5 minutes sends me a little piece of SAS code and says, here you go, Mary. This is how you get it and read it in. So hence started our particular journey using City Bike data. Now, City Bike is a bike share program in New York City. They have other programs like in Denver and Toronto and other places, but we're going to focus on New York City. And it's about providing access to bikes for people to kind of navigate and ride through the city. So who are we? We're M&N Consulting, Matt and Mary Consulting Company. Matt is the resident genius, and I'm the storyteller and a JMP user. The tools we're going to use today are SAS, R, and JMP. And we're going to show you how we used this particular data in our explorational journey. So what are we going to look at? We're going to look at the City Bike data. We're going to look at the data collection, data description, and the visualization flow. City Bike, as I said before, and I'll probably repeat numerous times, so bear with me, is a public bike sharing service. And they make their data publicly available on the web for you to consume. So all of their users can consume this data. They give you membership information. They give you availability. One of the things, if you go on the City Bike app, you can see when a bike's available or not available. And that becomes very, very important. Because if I'm going to get a bike, I'm going to pick it up, and if I ride it in less than 30 minutes, I get to ride it free. So it's going to be very important where I'm going to dock my bike. I want to make sure I have a docking station. I want to make sure when I walk outside my apartment in New York City, there's a bike waiting for me in the particular areas that I want to go. So will I have a bike, and where can I dock my bike become very, very important in my navigating of the city. So these are pictures I took. So here we have a full bike station, and here we have an empty one. So you can understand when it's full, I need to have a place to put it, and when I want a bike, it has to be at my fingertips. So the bike station data is available in JSON format, as well as a CSV file. And the membership information or the trip history information is available at random when City Bike makes it available for you. And the JSON information, or the files that are coming off the web, are real-time, updated every 6 minutes, so you can look at that data and look at actual patterns of usage. What is a JSON file? It's a JavaScript object notation. So it's used instead of XML, and it's a paired attribute value pair, and it's in a human readable form. I put this up because this is very important. This is this file, and there's no commas or white space or anything. So first off, we had to start with, well, how do we dissect this file and make it readable and then be able to bring it into JMP? And that's where SAS comes into play, and Matt will talk a little bit about that at the end on the SAS code, how it worked, and the magic that he had to employ to get this file in a readable format. Yeah. There are free JSON readers out there. I tried them, several of them, and ended up that Matt was faster. So thank you. So we extracted the files using SAS to parse the files. So SAS went and got it. We parsed it, put it in as a temporary file, and then we had to bring it into JMP. So it's a two-step process. And with R, we had to install two packages. One was HCTR, which works with the web connection, and then the JSON reader to read that JSON file. So once again, you have to read the file, parse it, create a temporary copy, and then bring that data into JMP. So after we got the data into JMP, this is where the fun began. I can't tell you how much fun I had, and every time I'd call Matt up, Matt thought I was on speed or something, because I'd be like, guess what I did? Look what I did, and I found if I do transparencies or make the marker mode faster or group things, and I learned so much more about the tool than I normally would have, only because I had to dig deep and do a lot more visualization. So we use Graph Builder, and Graph Builders are drag and dropped. We use data filters. We use bubble plots. We use the street level maps in JMP. I found some polygon maps, which is a JSON format, which I was able to read. And bless his heart, John Ponte, who's here, he actually answered the phone. Every time he saw the caller ID was my name. And so I thank him, and he helped me translate that. And then there's some other tools on the JMP website that I was able to use. I found a KML file format, which is another mapping format that there was an add-in for that I was able to use and create some polygons of the neighborhoods. Because that's what I was looking for. I had the street levels, but not being familiar with New York, I had to break data down also by neighborhood. And then custom icons, and that's thanks of Dan, the bubble plot person, created an add-in, and I was able to create custom icons, which are important in part of your communication. So with his help, I created bicycle icons to go with some of the visualizations that we're going to look at today. So what do we want to explore? What do we want to learn? Well, where are the bikes and how many are available? What are the docks and how many are empty? Who are the riders? Are there more males? Are there more females? Or tourists? Who rides and rents these bikes? What day of the week do they rent them? What are the popular neighborhoods? Are more people going from Union Square to Grand Central Station or Penn Station down to the financial district? Where's the ridership pattern and what happens with the availability of these bikes? And of course, overall station usage over time. Here we go, the live JMP demo. Any questions so far on the presentation? Matt, do you have anything you'd like to add?
How many folks have worked with the maps functionality in JMP? We got a few? Okay.
Great.
This is one of my favorite features.
Oh, yeah. So our first question is station usage. How are the stations being used? So just bring up my data table here, and I have a little map application that I started to write in JSL, and I apologize for the projector. It changes the display of my screen, so if I move around on my screen a lot, it's not because I can't find things, it's just the way it's proportioned. So this happens to be a bubble plot that has a little interface to it. And what's nice about this, what we did is I have a calendar that comes up. So I can go in the calendar, I can pick a date, and I'm going to actually pick the 15th, say OK, and I'm going to go to an end date. I'm going to pick the 15th again, and I'm going to change this time just to PM. Let's do it to 11. Say OK. And so I'm looking at February 15th, and I want to update, and I want to look at all stations. And thanks for a suggestion. I did put in a little message here, so when I draw more than 1,000 lines, you won't get worried about it. And so what happens is on this particular day, in this 24-hour cycle, there were 2,203 rides. So that's kind of informative, because now I can look at the number of bikes that went out in 24 hours. I might want to come in and pick a particular station. So maybe I want to look at one of my stations, Broadway and 53rd, and I might want to update and say, you know what, I know Broadway to 53rd, there was one trip during that 1 hour. So of those 2,203, I can kind of go through my application and then scale down and say, where were the frequency of trips? How were the stations being used?
Your question?
Start to end point. Yeah. No, they can bring it. I can go from Grand Central. You can go start A to start B. It doesn't have to be a round trip.
It gets checked out.
Checked out. Checked out.
So you don't track where it goes.
Oh, they do.
We do. Yeah.
We can get
We
that
can.
on.
We can get that, and that's part of looking at it big and then sort of drilling down, because I can get that information here if I want and just put in. I have my cheat sheet here. Just go down to west here, 21st Street, 6th Avenue, and say update. I have 19 trips, so I get a list of the stations. So, and you can see. Here, if we move this up, I have a pattern, and I can see the longest station away. I have distance information, as well as I can come here and select this particular item here, and we can see it was West Highland, 16th Street, High Line, and then I can drill down on that and actually go into this little application that I built. Yes?
You said distance information. Are these taxicab geometry distances? So when you get into modeling with distance, are you going to use how far they had to travel, or the area?
These are actually using the distance function in SAS, so that's a great circle distance, which is probably not so appropriate for Midtown Manhattan there. So taxicab might be a little better type algorithm. If anybody knows where such a function is, I'd be happy to hear.
And I reached back into my algebra days, and I'm like, longitude, latitude, I should be able to do seconds, and if I go to seconds, I should be able to go to miles, and then I was like, I called Matt. So here we are. So we can look at distances, but we felt because Manhattan is only so large, it really didn't matter per se how far they went. We just wanted to know the frequency between stations and actually neighborhoods. Because there's a lot of information here, so you have to group your information and break it down. So one of the ways that we did that was looking at gender, neighborhood, day of the week, and we broke it up in portion of the day. This was just a little add-on because we figured out how to, through the help of John, how to add lines. And so we can use these lines to look at and just visually see distance and where it is. And better yet, I can come with a magnifier and I can just begin to drill in and look at what's happening in the map and get really detailed, and just the flexibility of rescaling. So as we continue on with our journey, one other thing I forgot here that I will show you very quickly, and the beauty of this is if I come here and select February 19th, and I can actually type in, this is an interactive interface, and put in the 19th here, which I kind of like because as I was exploring and stuff and learning about the data, I was able to do this and say update. So during the week, I can see I had 8,000 trips. So there's definitely a difference between weekday and weekend, and what is that difference? So we start to begin our exploration and ask the questions. So where are the bikes and what are the available bike stations? And this one was a fun one for me. I'll leave this up to you, but I combined a graph builder window here, and so you can see here we have the bikes. Let's see if I can kind of scale it, make it so it fits. Anyhow, we have. Let's try this one. This one's a little better. So this is using the bubble plot, and we're actually looking at a particular neighborhoods here. I have a data filter behind the scenes, and this is the actual table of rows that we're looking at here. And so what's nice about this is I have a time, I have hour, I have the bubble size, and here you can see my icons, and they're little bikes. And we're going to scale this up here since we need to make this a little bigger. Here, let's do this. And we can look in particular neighborhoods. And this is just awesome when we look at neighborhoods and stations to use this magnifier just in the mapping alone. So you can see here, and this was kind of interesting for us. It's 10 a.m., and we're looking at the patterns of when a bike might be available and when a docking station might be available. And we definitely see a difference here. Let's make these bubbles a little larger so it's... And as I step through, and we go to 11, you can see there's a change, there's a pattern in the city between here we have a lot more available docks, but we have less bikes. And then this particular neighborhood here, and what is it? It's the East Village. And as we progress through, so we went through this, and we had a great time. And we noticed a pattern. So here we have a lot of available bikes starting at 1 a.m. in the morning, and we have less available docking space in this particular area. But in the main throes of the city, we have more docking space and less bikes. So we know we're going from residential area to more business area. And as we step through, you can see how it changes. And when we hit 7 o'clock, that was the biggest shift. So what happens at 7 a.m.? Why from this particular neighborhood in New York do we go over to this other, we start to have fewer docks, more bikes, and vice versa. So we saw a pattern in time in the way that the city, how people move through the city on their bikes, using the bubble plot and just using a time function to share and to step through that. And that was kind of funny because we went, aha, between 7 and 9, something happens. And then as we progress through here, we go to 11, and you can see here in the neighborhoods, we have fewer bikes, more dock stations. And as we get towards the evening, we sort of repopulate. And we're seeing this shift. And this is important because one of the things that came to mind was that in our research was restocking of bikes. They run out of bikes, and they have to hire someone to take bikes around the city and restock areas.
They put them on a truck and
They put them on a truck and load them up and put them back, or they empty stations out so there's room the next day. And one of the things that we were looking at this map was, could we have people return bikes in a way that you wouldn't have to rebalance them mechanically using, you know, someone going and finding the stations and repopulating or emptying? So this one was this. So this brings the first question is, what is the time of day usage? How are bikes used in the city? So that was kind of looking at time. That was data we collected every 6 minutes. And we just looked at 24 hours of it to get an idea of a pattern of a particular time. We could have grouped the data up a little bit more and looked at different time frames, but this we thought was best and reflective of what we wanted to look at. So now we have time of day, but what portion of the day? So we split the data up. And and this becomes important in how you label things in JMP. So we have portion of the day. Now I have to explain what portion of the day. Early morning is from 12 to 5. The morning commute is from 5 to 9, 5 to 10. Mid-morning is from 10 to 3. Afternoon commute is from 3 to 7. And then 7 to 10 is night. So it's important as you break your data up because this data is so dynamic and rich. You have to group it and put it in a manageable form. But when you look at this graph here, what do you see? What portion, what day, and what portion of the day seems to be most popular? It's Saturday and Sunday. Who is that? Is that a local New Yorker? Is that a tourist? Who is riding at those particular times? When we look at Monday through Friday, what's the pattern you see? You see more of the morning commute, and you see more of the afternoon commute. They might take the subway in the morning because it's raining, and they might take the bike home in the afternoon or vice versa. So now we're getting more and more questions about the data and how do we explore it. So this was kind of interesting to us. We're like, So we figured on Saturday and Sunday it was tourists, because who wants to get up early and rent a bike and ride around the city? Well, I would, but so that was interesting. And then we looked at the gender. Who's riding? What's their demographic versus males and females? And this one struck us because I have to explain this is based on membership information. I did originally have unknown, but I figured I would change it. I could have had alien or something, but I think late at night I just put other. But you can look at these distribution or these bar graph here, and there's a similar pattern in the bars. The males and females are members. So what happened was there was membership information. People that were members put their gender down. People that were not members that kind of used the bikes at random didn't put anything. They just was classified as other or unknown. And so we noticed here, if you look at day of the week, that we're seeing a lot of ridership on Sunday and Saturday. And that would make sense with our hypothesis and thinking about what day of the week is most popular for the tourist, or someone that's not a member or uses bikes infrequently. How does that help us? Not sure yet. If we look at just the males, we see we have more male riders than females. Make sense? Yeah, if I'm dressed up in a suit, I may not get on a bike. Who knows? But if you look during the week, we have more females riding on the weekend. Do they ride on the weekend because they run errands? They ride on the weekends because they're in their jeans and their sweatpants. Why do we have more weekend riders and females and more males during the week and less? So we started to use the data filter here and sort of looked at these. And what was nice is we could go through, and as we walk through some of these, we could add different information. We could bring in neighborhood. What does neighborhood play a role here? Let's look at Battery Park. Let's look at what happens there. Let's look at Chelsea. So we started to drill down in the actual neighborhoods to see if we could find patterns in this Saturday, Sunday gender difference and the tourists. So using JMP's data filter and the graph builder and having that flexibility, we were able to drill down and look at particular usage by neighborhood. And so this was kind of interesting to us on how the gender break happened. We bring this out, and I can just select females, and then we can look at East Village here and just see the ridership of what happens. So now that brings us to our next question. The neighborhood, what neighborhoods are most popular? What's happening? So then we decided to look at portion of the day and look at gender once again by what time of day. And then that's where we got this insight about the different times of the day that people ride and what the pattern is. You can see during the week there's more morning commute, less. And once again, we're just reaffirming or making sure our understanding and our patterns of recognition are making sense to us as we go through our particular drill down and as we learn and ask more and more questions. So the graph builder, the data filter are awesome ways to take large amounts of data and begin to drill down and understand the population and who's renting, how are they working and moving through the city. And then we looked at population by neighborhood. Now, colors are important in graphs, and everybody has a color choice. And colors and the type of graphs that you choose to portray information is subjective. I find this really nice because I like to pick patterns out really quickly, and I like bright things. I was feeling optimistically bright when I made this. But the point being is, this may not be the right graph for you, and that's the beauty of JMP. JMP gives me flexibility to pick a different graph to represent my information because I'm trying to put through a pattern here. The other is, I have to share with you, is like we went through, 14, 15 different iterations and combining data and grouping data and stuff, and then at the 15th try we got the right one. And that's the other thing, and John Saul stressed that earlier today. It's the flexibility of the tool and how we're able to take advantage and leverage the interaction. Now, getting back to my heat map here, we can see on Sunday, Park Slope seems to be most popular. And then we have our band of blue during the week. And so we're starting to see a concentration of neighborhood by day of week in that percentage. So that's helpful because maybe I want to drill down and find out, well, where do females ride their bikes? Do they ride them in a certain neighborhood because it's safe? Do they use them to run groceries, run errands? There's a farmer's market. Maybe it's city day in the city and Fifth Avenue's closed and they're out riding around. So we start to gather and get more information and start thinking about other ways that we can represent this data. So with that all being said, we decided to run a logistics model about is there a bike available or is there not. And it was very interesting to us because coming back to one of the questions was rebalancing, repopulating our information. Could we get our users to rebalance and repopulate bike stations or empty them? What was happening in the neighborhood? What was happening with gender and just kind of characterizing the ridership in New York?
Or even if there is a bike at the station or if there's a dock there when you need them. A fairly number of stations will go full to either one way or the other. So it's an item of interest to riders, and so that was something we focused on.
Yes. Yeah.
Citywide, what's the proportion of slots to bikes? Do you guys know those numbers?
We
actually,
looked at it at one time.
Do we actually have the actual? Yeah, we can get to that number based on what's in the data table.
There's enough docks for every bike. They could be all out of the system.
Well, I'm just wondering, are there 2 docks for every bike? Or, like, surely you would want more docks than bikes, you know, if there's huge usage.
You might want more docks available than bikes, but that depends on the neighborhood. And this is what this tells you, which is very, very interesting. This was kind of insightful for us because we found in a financial district, for example, the docking station's empty. They're empty in the morning, they fill up during the day, and they empty at night. We found in the neighborhoods to be the inverse. They empty in the morning, they fill up at night. So during the week, where the businesses are, the docks are always emptied for the first morning influx of people. So they empty the bikes there from these stations, and they bring the bikes around to different areas. Now, if we had more time, we could dig deeper.
For example, at the train stations, there's not enough bikes. You got to get a bike by 8 o'clock in the morning, or they all empty out at that point. And they even have a truck backing up the existing station docks there that they overflow on them. So they have, it's a real, could be a real interesting OR question for that rebalancing, but well, I would think that incentives for the participants in the program might be a very cost-effective way to help it self-balance a bit, rather than trying to put bikes on trucks and move them through city traffic in order to rebalance it night and day. Because there's a definite commuting pattern. Many folks, some of this commuting data here during the week, that's February. People are riding bikes to work in February in New York. So they're really dedicated riders there. So there's a diverse set of activities, diverse sets of usage patterns, and it's really helpful to explore the data to find out more about those.
So here we're looking at the East Village, because that one we kind of honed in quite a bit, because it's more residential, quote unquote, in the city. And we noticed here, if you look, we have quite a few bikes. And as we increase in the morning commute, and this is for Sunday, and then we go to mid-morning, you can see we have now more docks. So now we're just reaffirming our hypothesis. You know, is there a change? Is there a difference in neighborhoods? Is there a difference in location and the bike usage pattern? And then, as we saw earlier, we saw mid-morning and afternoon on the weekend was quite popular. So now we're looking, and now we have less bikes by the afternoon. By nighttime, it goes back up and repopulates itself. So certain neighborhoods are going to repopulate. So can we, how do they do that? Is there something that we can think of, putting some incentive in for membership, or bring the bike back and we'll give you a day free, you know, that type of information. If we take this same neighborhood and let's shift it over to Monday, you can see the interaction here. And if we come back to our morning, you can see there's bikes here. And then we go to our commute, and we're seeing the same similar pattern by mid-morning, and once again it's going up. So we're able to take a look using the profiler, JMP's profiler, and look at portion of the day, day of the week, in the actual neighborhood and how it's behaving with availability and not available. If we come over to the financial district here, the first thing we noticed was the inverse of the bikes and how they're being used. So if we go back to our morning, we have 98% the docks are open. They're all free. There's nothing. And then we come to the morning, it start to fill up. Mid-morning, we have more bikes than docks. And then we come down to our afternoon commute. People are heading out. And then we come back to our night where they're empty. So this was kind of interesting. And if we switch this over to Sunday, it flattens right out, because no one's going to the financial district, or Wall Street is on Sunday, can't make any money. So we were able to kind of use JMP's mapping to explore data, group data. We were use the visualizations in Graph Builder and the data filter. And we were able to kind of walk through and come up with who's riding the bikes, where are they riding the bikes, and sort of profile the neighborhood. So maybe we could come up with some marketing campaigns, or maybe we could advise Citibank on some incentives. Any questions on what I've shown in JMP? Yes?
Where did you get your latitude longitude data from? Do you already have that?
That was part of the data that Citibank makes available.
The neighborhood was not. The neighborhood was a data mashup we got from another source.
Yes.
Assigned stations to the different regions in the city.
Yes, we did drill down and look at that. We started to explore that, looking at patterns between neighborhoods, and that's kind of what came behind that app that we kind of bought. I bought the app, no, that we kind of built in the beginning to show station usage, because we wanted to look at the neighborhood patterns. And what's nice is that with a bubble plot like that, let's go. Let's see if it's here. I don't have it. There we go. Let's look at this one. We could come in underneath here, and we had the flexibility of showing the role. And if I put in here station name, I can put the neighborhood. And if I select this here, then I can scroll down and say split. And then I can actually see the neighborhood. If I right mouse click and I want to put a background map, I converted the KML file. I also put the polygons in for the 4 neighborhoods here from a Zillow website. You just have to go into customize and just, you know, make the lines a little bit more available. And you want to fill the missing shapes as black. And you apply that. So now we have the actual neighborhoods that we can begin to look at. And you know, when you look at the roles and stuff and the flexibility here, we were changing station names and grouping station names. We were using the magnifier to come in and look at stations. We were shifting and drawing lines and looking at start finish, because it was important. You can't look at the individual users, but you can look at particular stations in particular neighborhoods. Yes?
In another map, you can customize your icon.
Yep.
Is that a default in the jump, or you did some special in the JSON?
That was an add-in that's available out on the file exchange in the user community, and it's called Bubble Plot Editor. And you can choose a map file. And you can see I have one here. If I open it up, there's the icon. And now you can create your own customized icon. And it knows what bubble plots have open. Now, I like to have this for the graph builder if anybody's taking notes. Yes? Well, we probably could have if we were more religious about collecting the data on a regular basis, because we get bike IDs.
The bike, yeah, the data is not available for members, so you can't tell that a single member took 2 trips, one in the morning from this station to that station, then another trip later that day. The bikes are identified, but not the members. You can see the patterns. They're really, there's not a lot of pairings of neighborhoods to stations, start to destination. You pick any one station, and they all go to diverse locations. It might be a little available to tease some of that information out, but they're pretty diverse.
Right. And one of the things we did talk about was we had bike IDs. So we wanted to maybe run a model and look at the bike IDs and see what bike maybe was staying in a station and not moving, and see if we could track a bike. And so that was on the wishful thinking. We had a lot of things on the list. We had a ball.
Well, in general, though, I think the idea is generalized beyond bicycles. Anything that has a location component, retail location, other things that have stocks and fills and data flows, all can benefit from the general techniques.
Yep. So just backing up a second, if City Bike wanted to hire M&M, you know, these are some of the things that we might tell them. There's more male riders than females. Maybe we do some incentives some way. Maybe we hire somebody from, you know, the New York City School of Technology and Design, and we design a seat or a way for women to ride more bikes. Female riders prefer neighborhoods. So they're in certain neighborhoods. Where is that neighborhood? Saturdays, Sundays and Saturdays, mid-morning, afternoon are most popular. And how to manage bike stocking and what are the financial areas. Ridership in financial areas are pretty consistent. We have a pattern for that. So maybe because we have that pattern, we can eliminate that and look at more neighborhood-ish stuff. What we could show City Bike, and which we didn't really have time to show today, it was really hard for us to come through and figure out all the things we wanted to share, because we thought the exploration and just getting into the data and exploring it and coming out with a message was important. But we could do time series, neighborhood station usage, and look and see if we can do any forecasting and predicting going forward. Can we manage station needs? What are those needs? Modeling, understanding the effects on available bikes or docks, which we showed. And then we could look at additional data with City Bike. Retail locations. Can we improve foot traffic at certain stores? Is there an uptick around certain station locations, subway stations? Do people take a subway or a train and come in and pick up a bike and go? Restaurants and bars. Could we do something with a restaurant and bar? We give you a coupon instead of, well, take a cab or ride your bike. I don't know. That could be dangerous, but, you know, you can put incentive programs to get people more to use them. Was there more usage if we had the data from the subway maps, or when subway outages were, could we determine how that influenced bike ridership? So there's a lot of information out there that we could pull in and look at if we had the time and City Bike wanted to pay us. And as Matt alluded to, other industries that could use these same steps are the retail industries, insurance, banking. You know, where's the branch usage? What's the time of day? What are the popular locations? Insurance, where are the claims being filed? Types of claims, geographical. If we had weather, we could layer weather on top. And then, of course, employees. Are there alternate ways to commute to work? We found, actually, that Zillow had where city bike stations were based on their properties. So that was kind of interesting. Why, you know, that was a data point we picked up. And then, of course, stations must be accessible and easy to use in location, location, location. So M&M Consulting thanks you for taking the time to view our presentation. We are for hire for the right price, but you know, today we're willing to share our thoughts and how we use JMP to navigate and understand the data we were looking at and how we group that data to tell our story. Matt's got 3 minutes to tell you about the code.
Thank you, Mary. Just the parsing, it's a free text parsing. The JSON comes in as a single string without a carriage return. It's just one long line of data. And so the key, actually, with some help from the good folks at tech support, helped me parse this. And we can go with a file name URL. We can go directly pull up the input file. Then I write out a temporary file here after parsing a header record, because the JSON has this hierarchical structure, much like XML. And the first record is a date timestamp. And then we get to the second set of records, which is a grouping of stations. And each station ID is a logical row, but it's not separated. So there we can go. And the first one here, the hex item, the 0D, 0A is a carriage return line feed. So here we're parsing the string, and we're cutting that long single string into something more rectangular to read it in as a JMP data table. And then we write it out where each row is a station ID, but it's still one long string.
There's where you write it out.
Yeah. Then the other one on the SAS side here is the key value pairs in the JSON string. So we look for the label. We read at the label. We start reading the data right after each label. So we get them rectangular, and then we read key value pairs in the JSON string. R has some functionality that does basically the same thing. It's a little hidden, as it usually is, wrapped in a package. But the combination of these two packages will let you do effectively the same thing, to read in the JSON file. So it's text, you know, so it's free text. SAS in particular is very, very flexible for reading and parsing any text file. But it's string handling types of things. But I think we're out of time, so we thank you for your attention. Have a good afternoon.
And if you have any questions for Matt and I, feel free to come after, because we have a directory probably full of about 100 tables and different graphs and stuff. We'd be happy to talk to you about our journey. And one last plug to development. You know, I'd love to have those lines be weighted by the number of trips on my graph. Anyhow, thank you very much.